Aloha, everybody. This is Gigi from Kauai Community College. This is a video on subtraction strategies in base 10. So this is to be watched after you have already learned subtraction in different bases, right? So now we're focusing on base 10. So the definition of subtraction is to find the missing add-in in an addition problem. That is, it is the inverse of addition. So A minus B is blank if and only if B plus blank is equal to A. Particularly if you have 13 minus 5, the answer to that is the number that goes in the blank when you are saying the sentence 5 plus blank equals 13. And we all know that's 8, right? Okay, so subtraction is more complicated than addition because it has 3 different interpretations. Meaning when there are word problems, you'll see these scenarios play out differently. So there's 3 different ways that indicate a subtraction problem. And that is why it is a little bit harder to think about as a child learning about subtraction. So the most common thing that people will say is that subtraction is like taking away. Well, it is not always just taken away. And I'll show you what that means. So taking away is when you remove objects from a set or you decrease the measurement, right? So there's 2 ways that we see these quantities, either in a set model or in a measurement model. And here's what I mean by that. Here's a set model. Jessica has a dozen of cupcakes that she's bringing to a soccer practice. The team ate 7 cupcakes. How many does she have left? So here we have a set of cupcakes to begin with, and we're taking away 7. How many is left, right? So that is a set model for subtraction. Now, another scenario would be Jorgen has $21 in his wallet, and then he pays 16 for the movie. How much does he have left? Again, you have a certain amount, and then you're taking away, right? So that's one indication of a subtraction problem, taking away. Now, another thing that would indicate subtraction is the part-whole model, where a part of a set is specified, and we want to know what the other part is needed to make a whole, right? So you are looking for the missing part, looking for the missing add-in. Therefore, it is subtraction. So an example of that will look like this. Kindergarten class has 21 students. 16 of them are boys. How many left are for the girls? Now, we have a whole, which is 21. 16 is part of them. And what's the missing part? Okay, that is part-whole model. Or you could have something like this, right? So I loaded my kids to drive to Kokee. That's 48 miles away from my house. I drove 23 miles and decided, hey, I'm going to go ahead and stop at Kalaheo Cafe for lunch. How many more miles do I have left to drive after I eat? Well, so the whole is 48. The part is 23. And there's the missing part. Therefore, it is a part-whole scenario for subtraction. Looking for the mystery number, looking for the missing part. That is a subtraction problem. Okay, now another way that we would see subtraction as is in a comparison model. That is when we are comparing 2 sets or 2 measurement things, right? For example, I have 110 students. Lonnie, the other math teacher, only have 87 students. How many more do I have than Lonnie. Okay, now another measurement model would be Jessica weighed 65 pounds, where Jorgen only weighs 48 pounds. How much heavier is Jessica than Jorgen? So you're comparing two quantities, and that is the comparison model for subtraction. Now, in all of these scenarios, what we are going to do to digest the information in the next unit is to really look at the bar model for problem solving. And that's going to help more of the conceptual understanding of the story problems. But in this video, what I want to focus on are the strategies for subtraction, because there's just so many ways you can see subtraction, right? So let's go ahead and talk about some of the strategies. What do we know so far? We know that subtraction is defined as the inverse of addition. So all of the strategies for addition that we have learned from previous class will apply here if we just think of subtraction as an addition problem. Okay, so you have already all of those strategies that you have learned from the previous class period on strategies for addition. Now, what I want to do is to call out two very, very important strategies that really foster understanding of mathematics. The first one is the sliding method. Now, some people call this give and take. Some people call this give and give. I don't even know. Some people call this compensation, but compensation doesn't work the same way for subtraction as addition. So I think of it as the sliding method. Okay, what do I mean by the sliding method? Let's take a look. If we have 35 minus 18, well, 35 minus 18, if you are looking at the comparison model, we're looking at the distance, right, between 18 and 35. Like here is 18. Here is 18, right? And here is 35. Now, the answer to this problem is the distance between 18 and 35. That is our blank. So 18 plus 35 minus 18 is equal to blank when blank or 18 plus blank is equal to 35. That's the definition of subtraction, right? So now we can think of that right here as that distance. That's what the question mark is. That's what we're looking for. Now, that distance, if you keep that distance the same and say we're going to slide this to like a nice looking number, okay? What does that mean, to slide it into a nice looking number? Well, to me, a nice number would be like, say, 20. So I'm going to go ahead and slide 18 over to 20. That means I'm going to go up 2 units to 20. So here I am at 20. If I was to keep this distance right here, if I was to keep this distance the same, okay, I was to keep that distance the same. And I'm going to start right here at 20. Then where am I going to end when I draw this? Where's the other end going to be? Well, it's going to move forward however many units this is. So I'm going to have to move this forward, this 2 more units right here. So I'm going to end up right here at 37. Okay? Because if 18 get moved forward 2 units, this end 35 will get moved forward 2 units to 37. because the answer is that blank, that distance. And that distance is going to have to be the same distance, right? So we are saying now 35 minus 18 is the same as 37 minus 20, because all I am doing is taking that distance and move that forward 2 units. So both ends will have to move in order for that distance to stay the same. Now 37 minus 20 is a lot easier to think, and that is 17. Or we can think of it as 20 plus what is 37? Well, from 20, I could move up 10 units to make 30, and then 7 more units to make 37. Therefore, it must be 17. So the the difference, meaning the answer to a subtraction problem, is 17, right? But the concept here of the sliding method is like, think about it as like placing a ruler. You can move the ruler forward 2 units. And so if the end move forward 2 units and you keep that stick or that ruler the same length, then the front of the stick would have to move forward 2 units, right? So that is the sliding method. Okay, here's another problem to look at. So this right here is blank when 25 plus blank is equal to 93, right? All right, if you want to, you could go ahead and use addition using the open number line method and find out the answer. Okay, now here we want to focus on the sliding method. So the answer to this problem is going the distance between 25 and 93. Okay, so that is this distance right here. That's the blank that we're looking for. How do we make this nice? Where do we go? We could go backward or we could go forward. Okay? If we were going forward, how many units to go forward to make it nice? I think I'm going to go forward 5 units. And that will get me to 30. And if I was to keep this distance the same, this end going to have to move forward 5 units. So that's going to end up at 98. Right? So that's going to end up at 98. That distance is the same. So I'm going to try to mark the same distance here. This distance is the same from one dot to the other. That right there is the same distance, right? So 93 minus 25 is the same as 98 minus 30. And it's easy to take away groups of 10, right? So 9 groups of 10, take away 3 groups of 10, you have 6 groups of 10. So that must be 68. And that is the sliding method, right? How is that different than the open number line method for addition? If you were to think of it as addition, you would say, oh, hey, here's my 25. I have to go maybe up 5 units to get to 30. And I'm going to go 60 units to get to 90. But then I have to get to 93, so I'm going to go 1, 2, 3 more. And 93 is right here. So that would be 5 plus 60 plus 3, and that is 68. Therefore, 25 plus 68 is 93. And that is an addition strategy. But Aren't we talking about subtraction strategies here? Yes, we are. But subtraction can be thought of as an addition problem. So again, all of those addition strategies will work for subtraction, except for this nice sliding method that I want to focus on in this video. That is how you can make a subtraction problem nice. Just slide that difference, keep that distance the same, slide it to a nice number where you want it to be at. Okay, so let's take a look at this one. Here's 57, and here is 124. Do we want to slide forward or backward? I'm going to let you think about that. Slide it forward or backward. Give it a try. Pause the video and then come back. Seriously, pause the video. Try it on your own first. All right, so when you come back, you will see maybe then, maybe you have slide the problem forward, because that's what I would do. I would slide that over to 60, and if I slide that to 60, then this gonna get, that's plus 3. This is gonna get plus 3 also. So that is going to end up being the distance between 127 to 60. So this is the same as 127 minus 60. And I know 120 minus 60 is 60 because I know my double facts, right? 6 and 6 make 12, so 60 plus 60 is 120. So I have 67 as my answer. Okay, and that is how the sliding method works, how you make a subtraction problem look nice. Now, that's not very dramatic, right? This one is. Can you imagine having to go line up 400 minus 2568, and then what do you have to do? You have to go regroup the 4 to the 3. That makes this a full group of 10. But wait a minute, I don't have enough here, so I'm gonna have to go and regroup this one. That goes down to be a full group of 10, but I'm not there yet, so I'm gonna regroup one more over and make that a full group of 10, right? So that is a lot of thinking. How can we use the sliding method to make our life easier here? Okay. What's the problem with regrouping? Because there's a bunch of zeros, you have to regroup like 3 different times. So I'm going to go and slide these numbers to a nicer place. That would be the distance between 2,568 to 4,000. That's the distance between here and here, right? I'm going to have you pause and think about this for a second. Where should we slide it so that it is going to make our life a lot easier? Pause and think. When you come back after pausing the video, here's the trick. I'm going to slide it backward. I'm going to slide it backward. Just 1 unit back. And if I was to slide that 1 unit back, this is going to be what number is before 4,000? 3,999. What is going to be the number both 1 unit back from 2,568? 2,567. And that distance is still going to be the same distance. That blank that you're looking for, we're keeping that distance the same. We're just sliding it back 1 unit of both ends, so the difference doesn't change. So now, this 4,000 minus 2,568 is the same as 3,999 minus 2,568. Why is that so wonderful? 9 is the largest numeral you could write in base 10. So you can now just go ahead and subtract, and you don't have to regroup like this anymore. Okay, so now we can finish the problem. Not a big deal. 9 minus 8 is 1 in the ones place. 9 minus 6 is 3 in the tens place. 9 minus 5, 900 minus 500 is 400. 3,000 minus 2,000 is 1,000. And no problem. We don't need to regroup anymore, right? So the sliding method could be magic. That is very magical if you know what I mean. You don't have to go and regroup 3 times. Okay, and that is why I want to highlight this method. It's pretty awesome. The sliding method. Back and forth, no matter where you want to slide it, how much you want to slide it, as long as that distance stays the same. Now, do you only slide it once? No, sometimes we slide it to some nice number in the front. The back looks pretty nasty, so you make adjustments. So sometimes you have to slide it a few times to get it to be nice. But most of the time in an elementary classroom, sliding just one little nudge will make a big difference. Okay, so that's the sliding method. The other method that I want to talk about that has to do with the way we do addition or now subtraction in number bases, right? So don't forget what we have learned previously in any number base should also work for base 10, right? So if you have a problem like this, you can line them up. 324 minus 157. And you're like, okay, well, let's see how we go and do that. Remember, this is base 10. So when we were adding or counting, we were making groups of 10 to move forward. So when you move backward, you will have the exploding dot being a full group of 10. Okay, now I would go ahead. 2 is 1 and 1. This one right here gonna become a full group of 10. I would write 10 right there, and don't you go to think 14 minus 7. Do not think 14 minus 7. Why is that? Because 7 is always going to be smaller than a full group of 10. So you take 7 away from 10, that's a 3. That's your friends of 10. That is so much easier to think friends of 10 than to think 14 minus 7. So take 7 away from 10. That gives us a 3. 3 and 4 now is 7 left in that place value. Okay, let's do that one more time. In the 10th place on top, I only have 1 left. That's not going to be enough to take the 5 from. So I am going to need 1 exploding dot, and the 2 is left there. This exploding dot, when it goes down 1 level, it is a full group of 10. A full group of 10. Take 5 away from 10, I have 5 left, and 5 plus 1 is 6. And then the last place is nice. 2 minus 1 is 1. Therefore, the answer is 167. Just like how we were subtracting in other bases other than 10, right? We are the same process apply. And that kind of again proved my point of why we need to get out of our comfort zone and try to practice that with a different base before we learn about base 10. Anyhow, that is it for me for subtraction. I will see you in class when we have our Zoom session.